Okay, so for today, what we are going to look at is we're going to start the unsupervised learning, and that's the unsupervised machine learning part. And we are going to discuss one of the models that we use there, and that's the K-means clustering model. So, what is unsupervised learning? So, when we were starting our classes, we mentioned that unsupervised learning is a type of this is a type of machine learning class whereby we are dealing with data that has no labels, and we have to include labels to these data. So for example, you might say something like, let's say you are someone working in a park and you have different images of different animals. And for these different animals, you want to like group them into same categories. Okay. So if you've got these images, then you won't know like where each animal belongs to. So for example, on this side, you can have zebras. On this other side, you can have antelopes. And maybe down here, you can have lions. And what you differentiate them by is their size, their color, so things like that. So those are the different things that you differentiate these animals with. So what unsupervised learning does is it goes through the features that we have in each and every data point, and it's able to like classify that data into a specific group. So it's able to like create clusters of each data point that we have in our data. So when we are dealing with, for example, K-means, the first model that we will be discussing today, we will see how it works. So let's start and we will look at the theory part for K-means. So from the class notes, I think I've linked this in WhatsApp, but I can share this also here so that you can maybe check and have a look at what I'm checking. So here we have K-means. Let me see if I can zoom in, and then we can discuss. Okay, so here we have K-means. So K-means is a popular clustering algorithm used to classify a given set of n-dimensional points into K clusters. So these K clusters are the different groups that you can have, okay? So the algorithm is based on the concept of minimizing the sum of squared distances between each point and the center of the cluster to which it belongs. So you can think of it as a model that tries to like minimize the distance that a data point has to the center of a given group. So you can think of it that way. So overview. So K-means clustering is an algorithm used to classify or group objects based on attributes or features into K number of groups. So K is a positive integer, so it should be something from 1, 2, 3, 4, 5. So the different groups that you want to create from your data. And these features are what differentiates the data points that you have. So for example, if you have a picture, and from this picture you want to maybe check if what you have is number 1, number 2, number 3, number 4, and so on, what model can you use? So you can try use K-means for that. So maybe we'll try have a practical example on that. The goal of this algorithm is to find groups in the data with the number of groups represented by the K variable. So what this model does is it creates groups into these data that have similar characteristics and that are represented by this variable K. So if you specify your K to be equal to 3, then it means your data will have 3 groups. Okay. Then the algorithm works iteratively to assign each data point to one of the K groups based on the features that are provided. So what the model does is it has steps, and it follows these steps in grouping each data point to a given group. So for example, if you have 100 data points, so it will group these 100 data points following the steps they are that have been outlined by the model. Okay. So how does k-means work? So first of all, we have the random initialization. So it starts by choosing the initial k centroids randomly. So what it does is, for example, if we have this table here, so it will create, so for example, if you've specified your k to be equal to 3, it will pick 3 points here in within our data, which it will consider as our initial centroids. Then we have the assignment steps. So each data point that is here will be assigned to the closest centroid that it's close to. Okay, so you can see here, assign each data point to the nearest centroid. The nearest centroid is defined using the Euclidean distance. So if you go to the statistics part, you can maybe get to see how the Euclidean distance is calculated. But because for us, we are looking at the practical part, we will not go into detail as to how we calculate the Euclidean distance. And then what you do is you update the steps. So you recalculate the centroid as the mean of all the points in that cluster. Okay. So for example, if you had placed your centroid here where my cursor is, and you note that the mean for maybe the data points that are close to it is quite high, then you try adjust that centroid to be in a place where you minimize that mean so that you will have a small mean. And then you repeat all those steps till you get no changes or till you get minimal changes. So for example, this was our unlabeled data. After we've run the k-means model, we get the labeled data over here. So we will get to do this practically using the iris dataset, and you'll get to see how it works. And what are the advantages? So it's simple and easy to implement, then works well on small and medium sized datasets. Okay. Then what are the disadvantages? So you need to specify the K in advance. And the disadvantage of us specifying the K in advance is at times we won't know like the optimum value of K that we will need in this data. So for example, if you are given a data set that has no labels, how would you know that I'm supposed to use this K value when fitting my model? So it will be hard for you to do that. Then we have sensitivity to initial centroids and outliers. So if your data has outliers, so for example, from this scatter plot, and because this model is dependent on distance. So if we had data points that were far from the normal group here, it will affect the centroids of our data, and they will be placed in places where they are not bringing optimum results or not giving us like good groupings. Okay, then works poorly with non-globular clusters. So for example, if your cluster is not in this form, so you will find it hard fitting a k-means model. Okay, so I guess the next thing we will do is we will go to the practical part, and I'll show you how k-means work. Okay, so globular is just 3D based. So let's start the code work here. So I'll start by typing in k-means here, and then we can do the practical part of it. So I'll give you 2 minutes to create your new k-means notebooks. So the new k-means IPYNB notebooks, and then we can begin from there. Also, as you are creating your notebooks, I would like you to maybe share an update as to where you've reached with the project that I shared with you last week, because I think that will be important in me gauging your understanding as to what we've covered so far. So I want to see if you've understood the steps that we usually follow in creating ML models and in analyzing our data. So if you get time, please do share your notebook. Okay, so I guess we can start. And the first step that we usually follow is library importation. So I'll import libraries and we will have pandas as PD. Then we will import NumPy as NP. Then we will import Matplotlib as PLT. Then lastly, Seaborn. Then we are going to ignore all warnings. So we are going to import warnings, then warnings dot filter warnings. Then we are going to ignore all warnings. So that's the code we are going to work with. So for those who are using Visual Studio Code, or if you're using your Jupyter notebooks, so there is a free resource I shared with you, and that is Codium. So Codium has the ability to like share autofill your code, just as I'm doing here on my notebooks. So it's the equivalent of Google Copilot, not Google Copilot, but GitHub Copilot. Okay. And the good thing is for individual use, it's free. So if you check the pricing, you're going to see it's free and you can integrate it with Jupyter Notebooks. You can integrate it with Google Colab and you can use it on Visual Studio Code also. Yeah, so one more minute, you finish this part and then we can proceed. Okay, so let's proceed. So the first thing that we have to do here is we will import the iris dataset. And I'll have my iris dataset be equal to, I don't know if it's there on Seaborn, but we will try it out. So we will have iris.head, see if it's there. Okay, so here we have iris being equal to sns.load underscore dataset. Then we will have iris. Then iris.head, we get the top 5 rows of our data. So 2 minutes, you import the data and then we can proceed. Also, make sure your notebooks are connected to the internet for these to work. And since this is an unsupervised learning model class, we are going to ignore the species column. But I'm going to visualize the data, and I'm going to like use the species column to like make some few changes into the visualizations that we are going to create. And from there, we are going to feed a k-means model using these other four features. And then we will assume our data doesn't have the species column. And then we are going to recreate the plots that we will have done using the label that the model will have created for us. And then we will try confirm if what the model creates is close to the actual labels that the data has. Okay, so one more minute, then we can proceed. Okay, so I guess we can proceed. So what I'll do, okay, anyone with a question? Okay. So for the first code is just the libraries importation. So let me share these with you in the chat. And then the second code is the data importation, where we are loading the iris dataset. So I'll share that also in the chat. So just in case you're left behind. Okay. So here we've imported the iris dataset. And since this is a classification task, so what I'll do is I'll create a data copy, and we will have our iris copy being equals to iris. Then I'm going to drop the species column because we really don't need it here. Then axis should be equal to 1. Then dot copy. And then I'm going to type in iris copy dot head. So that's the data we have. So you don't have to create this now, but let me share that in the chat. So the most important part that we will have to work on now is creating the scatter plot. So I'll create a scatter plot with the hue corresponding to species. So here we can have SNS dot scatter plot. Then we can pick any of the columns that we have here. So here I'm plotting the sepal length versus the sepal width, then hue being equals to species. And then we can show our plot. So this is what we have. Okay, let me try change this to petal length, whereby we can see like we can get like a scatter plot that has some group distinctions. Yeah, so I think this should be better. So let me share this code in the chat section, and then I'll give you 3 minutes to work on it. Okay, so this is the scatter plot that we've created. So we can see, so as you are copying the code, we can see that down here, we have the sepal length against the petal width. So we can see down here for species setosa. So that is the iris flowers. So for the species setosa, they usually have a petal length that is in the range of 1 to 2. And for class versicolor, they have a petal length that ranges from 3 to around 5. But the sepal length ranges from 5 to maybe 7. And then we have class species Virginica, which has a petal length of around 5 to 7 and a sepal length of around 5.5 to 8.0. And clearly you can see here that with those distinct features, we have three different groups here. Okay, and these three different groups are in different locations in within our scatter plot. So if I was to maybe assume this data has no labels, just like we've done so down here, like we've created a data set that has no labels, and we want to create the labels for this data. So will it output a result that is similar to what we have here, or will the result be something totally different? So that's what we will confirm using the k-means model. So I guess 2 more minutes, you work on this and then we can proceed. So we can proceed. So hope you've got these filled. So this is the code for creating the copy. So you can copy that in the next 1 minute and then we can proceed. So another thing you need to note here is for unsupervised learning, you really don't have to split your data into training and test set. So you just have to work with the data as it is. So let's start by importing k-means. So we will have from sklearn.cluster import k-means. So by cluster here, it means that we are grouping our data into similar groups. And then what we will do is we will instantiate our model. And then we will specify our k to be equal to 3, or the number of clusters to be equal to 3. So we will have our k-means being equal to k-means, and then number of clusters should be equal to 3. And why am I using 3 here? So I'm using 3 because already up here you can see that our original data had 3 species. So what I'm trying to do is I'm trying to see if this k-means model can be able to like reproduce these 3 species as correctly as possible. So can we get a model that is accurate even without seeing the species column? Okay, so after creating the species column, we are going to feed the model. And here we are going to type in k-means.feed, and then we are going to feed this model to our data copy. So the data copy has the sepal length column, has the sepal width column, the petal length column, and the petal width column. So those are the things we are going to do. So copy that and then we can proceed. So 3 minutes you work on that, and then we can explain some few other stuff that we can do here. And another thing you need to note is when running this model on big data sets, so it's going to like take you time, and that's one of the disadvantage of using this model. So 2 more minutes you work on this and then we can proceed. Okay, so let's proceed. So after we've fitted our model, what we can do is we can extract labels from, we can extract labels. So we can extract new labels from our model. And one thing you need to note here is these labels will be in terms of numbers, and it will not be in terms of these species that we have here. And these numbers will represent the different groups that we have in our data. So to extract the labels, we type in k-means dot labels underscore, and that gives you an array of those labels. So what we want to do in our case is we want to, for this iris copy dataset, we want to add a new column called labels, and we will type in here iris copy, and then here we are going to say something like, okay, should be created groups, and then we are going to equate this to the k-means labels. And if we check our iris.head, you can see we have the created groups here. So that's how we create our data labels. So I'll give you 2 minutes to work on these and then we can proceed. So what we'll do next is we will so let me do that and then you can just finalize this part. So what I'll do is I'll type in sns.scatterplot and then here for hue, I'll change that from being species to created groups. And then for data, I'm going to use the iris copy data. And then I'm going to run that code cell. And you can see we have the same output that we almost had up there. So I don't know if I can add the CMAP. Let me set a good looking color and then we can. So I guess this should be more better. So copy these two code cells in the next 5 minutes and then we can proceed. Let me also share that in the chat for ease of copying. Okay, so I guess we can proceed. And the next step is just to explain what we are seeing here. So you can see, for example, for created groups, we have created group. We have group 0, we have group 1, and we have group 2. So I don't know if, let me see, let me see. There should be a way in which I can split this screen. Okay, so this should be better. So if I scroll up here, you can see we have this. So we have this plot here, which is for the original data. And we have this plot here, which is for the labels that our k-means model has created. We have some bits of weaknesses here, but you can see that the model tries its best to replicate the three groups that we have here. So for example, for class Setosa, this group has been perfectly split or has been perfectly excluded from the other groups. But for Versicolor and Virginica, where we have this part here where they are kinda linked together, not all data points are classified correctly. And that's one of the weakness of this model. So you don't expect it to be perfect, but at least it has created groups that are a representation of what we have here on the left-hand side. So if you are given a dataset that has no labels, you can use this model to create the labels that you can rely on. So for example, if you're working in a sales company and you want to group your customers into groups of good performing customers and bad performing customers, you can use this model to do that. And after you've done this, you can maybe proceed on and do separate EDA works on that, whereby you're going to explain and say that these are the characteristics of my bad paying customers and these are the characteristics of my good paying customers. So I was actually considering us doing a project on that tomorrow. So I'll get a data set and then we will work on that tomorrow. So the last thing that I'm going to show you is how do you visualize the centers, the cluster centers here. So what I'm going to do is I'm going to create a cluster plot again. With the centers now included. Okay. So this is what we have. So the centers are not that perfect, but this is what we have. So let me try extract the k-means centers. So this is what we have. So we have that, and that. And they are not that perfect because you see in our data set we had a four-dimensional data, but the kind of plot that we are creating here is a two-dimensional plot. So we would expect something like this where the centers are not maybe in locations that are that much perfect. So that brings us to the end of this code part. So I'm just going to include an explanation to this code here in the notebook, and then you'll check that later. But also in the notes, we can go through what is there. So we have a code sample here, and for this code sample, we are generating synthetic data. So we are not using real world data, but we are generating synthetic data. And here you can see, for example, I included 4 centers so that when I was creating my model here, I use the number of clusters as 4. I fit the model, then I get the model labels, and then you can get the centers of your model. And after doing that, you can plot your model using the centers. So I can copy this code, the whole of it, and then I can run it down here. So you don't have to do this now. So you'll do that once I share the notebook. And if I run this, let's see what we get. So you can see, since our data is a perfect 2D data set, you can see the X's that are here represent the distinct groups that we had in our data. So that's basically how the k-means dot cluster underscore centers does. So it gives you the centroid of each group. So you can see that these data points are concentrated in areas where we have those centroids. Okay, so that's what we have. So the last thing we are going to look at is these practical applications. So what are some of the areas where we can apply k-means? So we have customer segmentation in marketing. So as I've mentioned before, we can group customers as good performing customers or bad performing customers. So with the data that comes in from the market, you are not able to like directly say that this customer is good or this customer is bad. So you have to check the underlying characters of each customer and you have to group them. And from those grouping, you will be able to like say these customers in this group are reliable and these customers in this other group are unreliable. Then we have clustering genes in genomics. So this is in healthcare. So if you are dealing with gene data, you can group the different genes together. Then we have news articles clustering. So for example, for blogs that we have online, so if you go to Google, so there are systems that are at the back end that are used to like, for example, if you say football news. So there is an algorithm in the backend that is able to like classify if a blog is a sport blog or if a blog is a maybe let's say a weather news. So something like that. So how does Google do this? So it uses similar models, not necessarily k-means, but other better models to like do this. And we can also try work on a project based on this. So that's all for today from me, not unless you have questions. Anyone with a question? Yes. Yes,
Hello.
Jesse. Hello.
How do we detect and treat outliers in such a model? And do they have an impact in the final results?
Yeah, as I mentioned before, so outliers is one of the advantages that we have here. So to treat these outliers, I guess in most cases you have to remove them, or you can maybe try look at other characteristics of these outliers and maybe move them to a group that has similar characteristic to it apart from maybe those things that make it an outlier. So for example, in a case whereby you are looking at a customer segmentation task, so you might have clients who are maybe young in that market. So let's say the average age or the median age in that market is 40. But you find an individual who is aged 100 and above. So how will you treat that client? So you see, you'll have to like step in and be less reliant on your code work and decide yourself, how will I like group these customers? So should I group them in the good paying customers or should I just leave him out? So things like that. So that calls for intuition, whereby you'll have to make the decision yourself in most cases. Is that okay?
Yeah, that's okay.
Okay, great. Anyone else with a question?